Hello dear students and welcome back to my channel. In this video we are going to see a problem from integral calculus, also known as multivariable calculus, in the current syllabus. This question is from examination of semester 5 of October 2016 and it depends on line integral of a vector field. So let us first identify what is line integral of a vector field. The definition of line integral of a vector field capital F over a curve C is given as integration of f applied on alpha of t dot product with alpha prime t dt and the limits of t if it is from a to b. Over here, alpha is defined from the domain closed interval a comma b in R to Rn, and it is known as the parametrization of the curve alpha. Now if we will focus on the question, we are given a vector field over here which is f of xyz equal to sine of z I hat plus cos of root y j hat plus x cube k in the vector form, which can also be written as sin z cos root y x cube in the Cartesian form. And it is said that C is the line segment from 100 to 003. So the very first thing which we are going to do is we are going to parameterize C. So to parameterize C, we need to define alpha. Now since alpha is a line segment, we have a standard formula for parameterizing a line segment alpha from 0, 1 to R3 here, since our line segment is in R3. So alpha from 0, 1 to R3 given by alpha of t equal to 1 minus t into p plus t into q, where p is the first point of the line segment and q is the last point of the line segment. So in this case we will have 1 minus t multiplied by 100 plus t multiplied by 003. Upon simplification, we will get 1 minus t, 0, 3t. So this is our parameterization of the line segment. Now we will move forward on the definition of the line integral. So if you will look at the line integral, we need to find out f of alpha t and alpha dash of t and then followed by the dot product. So firstly we will find f of alpha of t. So f of alpha of t means f of 1 minus t, 0, 3t. Now if you will look at the definition of f, so what f is doing to xyz, it is mapping x comma y comma z to sin z cos of root y x cube. So this is going to be sin of z, that is sin of 3t, comma cos of root y, that is cos of root of 0, and x cube, that is 1 minus t whole cube. So this is going to be sin 3t 1 and 1 minus t whole cube. Also we need alpha prime t or alpha dash t. So alpha dash t is going to be the derivative of this quantity, which is negative 1, 0, and then we need the dot product of f of alpha t with alpha dash t. So that is going to be sin 3t 1, 1 minus t whole cube, dot product with negative 1, 0, 3, which simplifies to minus of sin 3t plus 0 plus 3 times 1 minus t whole cube. Now moving on to the definition, let us just look one more time. So line integral over C is integral of f of alpha t dot product with alpha prime t, which we have got over here, and the limits of t, which is from a to b. In this case we have the limits of t from 0 to 1. So therefore line integral of f over c is going to be line integral over 0 to 1, then minus sine of 3t plus 3 times 1 minus t whole cube dt. Integral of minus sine 3t is going to be cos 3t with a negative sign, and then integration of 1 minus t whole cube is going to be 1 minus t raised to 4 upon 4 and with a negative sign. So we can just replace this with a negative sign. The lower limit of t is 0 and the upper limit of t is 1. So putting the upper limit, this will be cos 3 upon 3 minus 0. Then putting the lower limit, we will get cos 0, so that this will be 1 minus, if you will put t equal to 0 here, we will get minus 3 upon 4. So this simplifies to cos 3 upon 3, and the second bracket simplifies to minus 5 upon 12. So minus 5 upon 12, you can simply write it as plus 5 upon 12. And just to have it on the same denominator, this is going to be 4 cos cube plus 5 upon 12.